And then now re tlo ba re focus on finding the acceleration and the force ge le gore the objects are in contact. E re lebelle this example mo re na le two objects that are in contact. So re nyaka tlo find out the acceleration because these objects di tsamaya together, e rela gore di na le the same acceleration. Every time ge re na le a situation whereby the objects are in contact, re tlo šomiša Newton's third law. Ge e le gore re na le these objects mo e le gore they are in contact, let's say this is object A and then this is object B. Re tlo šomiša Newton's third law. Newton's third law actually e re when body A exert a force on body B, body B exert the same force on body A but in opposite direction. Ge e le gore these objects di in contact, e rela gore body A e create a force on body B and then body B e create the same force on body A. Ge e le gore the force ya A on B, force ye le gore A e pusha B ka yona ke 10 newtons. According to Newton's third law, e re this B you feel the same force ya 10 newtons but in opposite direction. So more to apply Newton's third law. More na le 4 kilogram block and then is in contact le 2 kilogram block. E rela gore this 4 kg go na le a force ye le gore ya exert on 2 kg. And then because these objects are in contact, e rela gore le these 2 kg e exert the same force on 4 kg. Ga re tsebe gore ke force ya bokae, but those forces ke nyaka di name gore ke x. Ke tlo di name gore ke x kaofela because di a lekana. And then now re tlo draw ya a free body diagram. E re draw ya 4 kg first. Mo re na le a weight force which is downwards, and then re na le a normal force that is perpendicular to the surface. Because this is our surface, e rela gore this must be a normal force. And then for this object ga re ne frictional force because as ba re botša ka frictional force, but re na le force applied which is 50 newtons. This force applied e pusha this 4 kg block to the right. Ge re draw ya a free body diagram, re nyaka gore a force e move away from the point, ga re nyaka gore e approach a point. So that is why ke drawile in this way, because it's the same thing. Ge e le gore object re pusha in this direction or re goga in this direction, it's only the same thing. So mo ke na le force applied, and then this force applied ba re file gore ke 50 newtons. Re na le another force. Remember gore re kwane gore this 4 kg you pusha 2 kg to the right, and then e rela gore le this 2 kg you pusha this 4 kg to the left. So rela gore mo re na le a force ye le gore re tla bitša gore ke x. Now a re draw ye a free body diagram ya this 2 kg. Re na le a weight force and then re na le normal force, but this one ga re ne force applied because this force applied ke ya this 4 kg as you can see here. So rela gore for this 2 kg block re na le a force ye le gore ke this one. Remember gore this 2 kg e pusha this 4 kg to the left, and this 4 kg le yona e dira the same thing, e pushetša to the right. So rela gore mo re na le a force, and then ke tlo bitša gore ke x. So now ke tlo dira f net ya these two objects. A re thome ka ya 4 kg. Ke tlo re f net e lekana le ma, and then ra dira the same thing ka ya 2 kg. Ke tlo re f net e lekana le ma, and then now re tlo substitute ka f net. Remember gore f net e no ba the vector sum of all forces acting parallel to the direction of motion. Object ya rena in this direction because ka kgona bona gore this force e pusha to the right. So now ro lebella the forces tse di parallel to this line. O ka kgona bona gore ke force applied, and then le this x the parallel to this line. But because this force applied here in the direction of motion, remember object here to the right and then the force applied to the right. So rela force applied here over positive, and then this x here over negative because it acts in the opposite direction. So rela from there ke force applied and then got minus x and then got equal to ma. Re tlo dira the same thing ka this one here 2 kg, but mo ka lemoga gore re na le only one force is parallel to the surface, and then ke force ya x e acta to the right. So re la gore ke tlo re x equal to ma, and then now let's substitute. So more na le force applied but feel ke 50 newtons, so ke tlo re 50 and then minus x e lekana le ma, and then mass ke 4, and then acceleration re nyaka yona. So from there ke nyaka o dira this x subject of the formula. This one already o ka kgone bona gore ke subject of the formula. So re la gore ke tlo dira this one, ke tlo re 50 minus 4a equal to x, and then this one ke tlo e bitša gore ke equation 1, and then this one ka e bitša gore ke equation 2. But e re substitute first, ke tlo re x equal to 2a. So re la gore this is our equation 2, and then from there because re kwane gore this forces di a lekana, because ka kgone bona gore ke di x ka moka, e re la gore ke tlo re 50 minus 4a e lekana le 2a because more na le di x kaofela. So re la gore from there I will say 50 minus 4a e lekana le 2a, and then now let's solve. Ke tlo re 50 e lekana le 6a because ke jere this minus 4a ka isha to the right and then you have a positive, and then now because re nyaka acceleration ke tlo divide both sides ka 6, and then re la gore acceleration ya rena e tlo re fa gore ke 8.33 and then meters per square seconds. So now re kry-ile acceleration. This question it really find the acceleration of the system, but no rela gore find the acceleration ya these objects kaofela. But because re tseba gore di tsamaya together, e rela gore acceleration is the same. And then again ba re find this one, the force ya 4 kg block xz on 2 kg. Remember this x and this x they represent a force, and then from there answering this question re nyaka force ya 4 on 2 kilograms. Re nyaka tseba gore this 4 kg e create a force ya bokae on this 2 kg. So re la gore from there ke tlo re f4 on 2, and then ka re lekana le ka substitute anywhere mo ke nyakago because this x and this x is the same thing. So now let's substitute. Ke tlo substitute here because this one is very simple. So ke tlo re lekana le 2a, and then on this a ka substitute ka 8.33, and then from there it tlo fa gore ke 16.66 newtons. So re answerile this question. Ge o nyaka o ka tšea this acceleration wa substitute here, o tlo kry-a the same thing, but o make sure ya gore o ba specific ya go answer this question. O ska re x o ba botše gore o nyaka force ya 4 on 2 kilograms or force ya 2 on 4 kilograms. So this is our answer anyway. Let's see this one. Here a 10 kg block rests against a 15 kg block on a rough surface. A 100 Newton horizontal force is applied to the 10 kg block. The 10 kg block experiences a frictional force of 7 newtons, while the 15 kg block experiences a frictional force of 10 newtons. Determine the magnitude of the acceleration of the system and the force the 10 kg block exerts on 15 kg block. More nearly the same situation, just that now nearly frictional force. This object is nearly a friction and then the same as this one, but to apply the same concept. For the reason this object is in contact, re apply Newton's third law. This 10 kg block you exert a force on 15 kg, and this 15 kg block you exert the same force but in opposite direction. So this force is x. So now I'll draw here a free body diagram here, this 10 kg block. Ranally a weight force which is downwards, and then ranally a normal force that is perpendicular to the surface. This 10 kg block inally force applied is to the right, so more of force applied, and then mobile feel friction, and then friction pila opposite to the direction of motion. Object here to the right, friction in the opposite direction, so more a friction. And then more another force. Remember this 10 kg it push 15 kg to the right, and then this 15 kg leona it did the same thing, it push to the left, so more a force that is called x. And then now let's see this 15 kg. Ranally a weight force which is downwards, and then ranally a normal force, but more force applied, but ranally this friction, because ranally friction, so ranally friction that is opposite to the direction of motion. And then this 10 kg it push this 15 kg to the right, so more of force x that is to the right. So now the F net. F net elegantly MA, and then the same thing this 15 kg. So now let's substitute. This F net the forces the parallel to the surface, ke force applied, ke x, and ke friction. But this x and this friction the opposite to the direction of motion, so do over negative, and then this force applied do over positive. So get force applied, and then minus friction, and then minus x equal to ma. So now let's see this one. More nearly x is in the positive direction here, a direction of motion, and then this one is in the opposite direction, so x minus friction, and then equal to ma. So now to substitute. So let's substitute. More nearly force applied 100 newtons, and then friction 7 newtons, and then minus x equal to 10a. And then as for this one, this is x, and then minus a friction here, this 15 kg, but 10, and then this mass 15. So from there on this one nga add the like times first. 100 minus 7 ki 93, so kanali 93 minus x equal to 10a, and then kitudira this x subject, kitluja this negative x kaisha to the other side, rela rukobali 93 minus 10a equal to x. And then as for this one, ke tlo tšea this negative 10 ka iša on the right hand side. So re la re ko ba le x e lekana le 15a plus 10. So I can say this is equation 1 and then this is equation 2. So from there ke tlo re equation 1 e lekana le equation 2. So now re tlo equate, re la gore ke tlo re 93 minus 10a e lekana le 15a plus 10. So now a re group di like terms, ke tlo tšea this 10 ka etiša on the left hand side and then ya ba 93 minus 10 and then re la gore ko ba le 83 and then ke tlo tšea this negative 10 ka iša to the other side and then ya ba positive ka ba le 15 plus 10 and then ya re fa 25a. So from there, because ke nyaka acceleration, re la gore ko divider both sides ka 25 and then ge o ka divider both sides ka 25 e tlo fa gore acceleration ke 3.32 meters per square seconds. So this is the acceleration, and then now ke nyaka go find out this force here 10 kg on 15 kg. So now ke tlo substitute anywhere, ke tlo substitute here ka re x e lekana le 93 minus 10a and then ka re 93 minus 10 and then acceleration re kry-ile gore ke 3.32. So from there it tlo re fa gore ke 59.8 newtons. And then now ke nyaka go ba specific, ke tlo re f ya 10 kilograms on 15 kilograms e lekana le 59.8 newtons. So this is our answer ya find the force. So that's it for this question and that's it for this tutorial.